Here we are looking at May-June 2023 Pure Math 4 paper. In the previous video we solved question number 1 to 3. So let's look at question number 4. This is from chapter 7, vectors. We have a position vector of 3 points A, B, C. So when they say position vector, this is basically OA vector, OB vector and OP vector. The straight line L passes through A and B. Find the vector equation of A and B. Find the vector equation of L. So first you need to find AB vector. Remember this rule, OB minus OA. That's a very important rule here. So OB is 5, 6, 3 minus OA is 4, 8, 1. So we'll get 1 minus 2, 2. So we can straight away write the equation R is equal to, write any one of the position vector of any one of the point. Up to you which one you want to use. I'm going to use the first one, 4, 8, 1 plus lambda times AB, which is 1 minus 2, 2. That's all. That's the vector equation of the line passes through A and B. It's an easy 2-mark question. Let's move on to part B now. Part B says point C lies on L so that PC is perpendicular to L. Part B says the point C lies on L. Okay, we have the equation of L actually. I'm going to write the equation of the line, which is 4, 8, 1, 4, 8, 1 plus lambda times 1 minus 2, 2. That's the vector equation of the line L. Let's say this is line L. And we have a point C that lies on L such that PC is, let's say P is somewhere here. PC is perpendicular to the line. Okay, if a point lies on a line with this vector equation, for every point there will be a value of lambda associated with it. But for this C, we don't know the value of lambda. So usually when you know the value of lambda, let's say for this C, the lambda is given as 1. You sub in here, you can find OC already. You can write OC vector as 4, 8, 1. Lambda is 1. So 1 times this, you will get the position vector of the point. So you need the value of lambda associated with the point. But here it's not given, so we are going to consider it as just unknown. Take it as just lambda and find OC vector. Since the point lies on this line, this will be the position vector of any point. It's going to be 4 plus lambda, 8 minus 2 lambda, 1 plus 2 lambda. That's the position vector of C. And we already know the position vector of P given in the question, which is 2 minus 2, 1. 2 minus 2, 1. Now listen to me carefully. This vector, PC vector, is perpendicular to the line. So you must have learned this in scalar product. If two vectors are perpendicular, the dot product of the vectors will be equal to 0. So in this case, the dot product of PC vector dot the straight line. We don't take the whole straight line, we always take the direction vector, the one associated with lambda. 1 minus 2, 2 is equal to 0. So PC vector is OC minus OP. OC minus OP is, probably you can find PC vector first. OC vector minus OP vector, which is 4 plus lambda, 8 minus 2 lambda, 1 plus 2 lambda, minus 2 minus 2, 1. So you will get 4 minus 2 is 2, 2 plus lambda, 8 plus 2 is 10 minus 2 lambda, 1 minus 1 will be cancelled, 2 lambda. That's the PC vector. So we are going to sub in PC vector here. PC vector dot the other vector, the direction vector of the line, is equal to 0. So we write PC vector 2 plus lambda 10 minus 2 lambda and 2 lambda, that's PC vector dot the direction vector of the line is equal to 0. Why the dot product is 0? If two lines are perpendicular, the dot product of the two, if two vectors are perpendicular, the dot product will be 0. So multiply 1 times 2 plus lambda minus 2 times 10 minus 2 lambda plus 2 times 2 lambda is equal to 0. Make lambda as a subject. So we'll get 2 plus lambda minus 20 plus 4 lambda plus 4 lambda is 0. You get 9 lambda is equal to 8. 18 lambda is equal to 2. We got the lambda is equal to 2. That's the value of lambda corresponding to this point. So to find the coordinates of the point or the position vector of the point, we take the straight line and then replace lambda by 2. So we take the straight line L, R is equal to 481 plus lambda times 1 minus 2. Sub in the value of lambda here to find OC vector. You will get 481, lambda is 2 times 1 minus 2. So we'll get 4 plus 2 is 6, 8 minus 4 is 4, 1 plus 4 is 5, 6, 4, 5. Why I am not writing in the vector format? Because they want the coordinates, they are not asking about position vector. So 6, 4, 5 is the point C. That's all. Let's move on to the next part of the question. Point P dash is a reflection of P in the line. So you have the line L and let's say you have P here and we know this is PC, which is perpendicular line, and we have another line P dash, another point P dash here, which is a reflection of this point P. They want you to find the coordinates of P dash. First let's find the position vector of P dash. We don't know where the origin is, just assume somewhere here. You can take anywhere, doesn't matter. We need to find OP dash actually. We need to find OP dash, that's a position vector of P dash. OP dash is same as OP plus PP dash, right? You can write it as OP vector plus PP dash vector. OP vector is given in the question. 2 minus 2, 1, 2 minus 2, 1. PP dash is same as 2PC actually, because these two vectors will be equal in length and in the same direction. So it's 2PC vector. So 2 minus 2, 1 plus 2 times, we have calculated PC vector already in the previous part. You can use that, or you better use that. Since I rubbed it off, I'm gonna use OC minus OP again. We got OC as 645 OC minus OP. Simplify, you'll get OP dash. So it's going to be, probably I'll write one more step, 2 minus 2, 1 plus 2 times 6 minus 2, 4 plus 2, and then 5 minus 1. Simplify this. When you simplify it, you will get 2 plus 8 is 10, minus 2 plus 12 is 10, 1 plus 8 is 9. That's the position vector of P dash, but they want the coordinates actually. Write it in the coordinate form, point form. This is the point P dash. That's all. Now there is one more part. They want you to find the modulus of PP dash. The modulus of PP dash, the length from here to here, is 2 times PC. So you can write modulus PP dash is equal to, you can either find PP dash vector, that's OP dash minus OP vector, and then find the modulus, or you can find 2PC vector, modulus of PC vector. It's the same thing. So we have a PC vector here, which is 4, 6, 4. So 2 times modulus of 4, 6, 4. That's PC vector. So when you find the modulus, it's going to be 4 square plus 6 square plus 4 square. 2 square root of 4 square plus 6 square plus 4 square is 4 root of 70. That's all. That's the answer. Question number 5 now. Integral x square e power x dx. They have asked this question several times in Pearson Edexcel board exam. The variation of this question. You need to apply integration by parts twice actually. First you use detail to find out what is dv. That's what I use. Some students they use liate to find u. Some of them they use late. It's all fine actually. So I'm using detail. We have algebraic function and exponential function. The exponential comes first. Take it as v. E power x together with dx. Take it as dv. Integrate both sides to find v. And the balance function, take it as u. So du by dx is 2x, du is 2x dx. Now the rule for integration by parts is integral u dv is uv minus integral v du. U dv is the original function. E power x dx is equal to uv x square e power x minus integral v du. E power x times 2x dx. Now we are going to apply integration by parts here again one more time. So this time dv is the same, u is just 2x, the rest all same. So du by dx is 2, du is going to be 2 dx. So keep the first term as it is and apply integration by parts here again. uv 2x e power x minus integral v du 2 e power x dx. And then open the bracket, x square e power x minus 2x e power x plus 2 integral of e power x is the same. Don't forget to add plus c. That's all. It's a 4 mark question. Sometimes they will mention some limit here 0 to 4 and all. What you need to do, forget about the limits first, get the integration and finally instead of plus c, finally sub in the limits 0 to 4. That would be easy. Let's move on to double A of this question. It's a 6 mark question. Use the substitution square root of 1 minus 3x to show that the value of this integral can be written in this form. Okay, so first we need to slowly convert everything in terms of u. You see what I'm gonna do? 27x divided by square root of 1 minus 3x dx is equal to integral. We know square root of 1 minus 3x is just u. And then we need to find 27x first. U is square root of 1 minus 3x. Square both sides. U square is 1 minus 3x. Make 3x as a subject, you will get 1 minus u square. We need 27x, so multiply both sides by 9. You get 27x is 9 times 1 minus u square. So I'm going to replace this by 9 times 1 minus u square. So carefully, step by step, you convert everything in terms of u. Now we are left with dx. So from here you can apply implicit differentiation. 3 dx is equal to 1 becomes 0 minus 2u du. 2u du. So dx is basically minus 2u over 3 du. So I'm going to replace dx by minus 2u over 3 du. So we can cancel u and u because it's in multiplication. 3 3s are 9. And then maybe multiply this negative inside, or you can just put the negative 6 outside. 3 times minus 2 is negative 6 outside. Integral 1 minus u square du. So we are at this step, we need to write the answer in this form. So first integrate it, minus 6, 1 becomes u square becomes u cube by 3 plus c. Initially we have taken u as square root of 1 minus 3x, which is basically 1 minus 3x power half. So sub in the place of u here and then multiply through it by minus 6. So minus 6u, u is this. When you multiply this and this, 6 and 3 can be cancelled. You get positive 2u cube. U is power 1 over 2, u cube is power 3 over 2 plus c. We need to take minus 2 as a common factor out, okay? And then 1 minus 3x power half as a common factor out, okay? So in the first term you will be left with only 3. In the second term you will be left with minus, because you have taken minus 2 out, only 1 minus 3x power 1 plus, put it as k, not c, they want k. And then that's all. Simplify what's inside the bracket. You will get minus 2, 1 minus 3x power half. You open the bracket and simplify. 3 minus 1 is 2. So you will get 3x plus 2 plus k. So a is 3. You don't need to write a and b separately. That's it. That's the answer.